Wouldn't it be nice if you could just type your text and let After Effects take care of generating solid borders? For a long time, I've wanted to have automatic borders for each line I add to a text layer. It should have been a built-in feature, but anyway, now that I know how to do it, I feel very excited to share it with anyone who cares for a deep dive into expressions. By the end of this video, you will learn how to set up 2 different practical projects, which you can save as templates and reuse on any other job. You're already watching the first example in action. It's a text revealing effect, handy for all kinds of infographics. The setup is fully procedural. The borders will automatically fit each line of text, no matter how many lines you have. You can adjust the overall font size, alignment, and leading also, without breaking anything. On top of that, you could have different colors per line and also animate those lines moving on and off the screen procedurally using expressions. I'll show you how to do this without overflowing the composition timeline with countless layers of text and shape layers. All in all, we'll make use of just 2 text layers. The second example will reveal a soccer team formation scheme like the ones you see prior to the matches. Apart from updating the players' names, you will also be able to change their positions on the field in real time using a simple mask shape. The names will stick to the ground no matter how you move or rotate the field around. I'm sure you'll find this kind of project very useful for sport-related jobs. Let's get started. In a new composition, add a new text layer and rename it Main Text. Let's enter some lines of text. Line 01, second line, 3, and 4. I make sure that every line is different in length. Trim the layer so you don't have to preview all the comp just for tests. To get the bounding boxes, we'll make use of the source rect at time expression. You'll probably think, aren't there tons of tutorials all over YouTube explaining just how that expression works? But please don't run away yet. There is a catch. The source rect at time expression returns you the bounding box dimensions of any layer, true. In our case, it will return the dimensions of all lines as a block, not any line in particular. My solution is to split our source text into lines and show each line apart from the rest in a single frame, then use that frame number as a reference for the source rect at time expression. So, the main text layer will have a dedicated segment of frames where each line of text will appear solo. You can have that segment at either start or end of the layer. I chose to have it at the end because it's easier for me to disregard the last frames of a layer instead of the start. Before anything else, expand the More Options group of properties and set the anchor point grouping to lines. This will make sure that we only view one anchor point or cross sign per line later on, as opposed to one per character. Add a scale animator, rename it to Solo Lines, and replace the range selector with an expression selector. Switch it based on lines. Erase the default expression for the amount property and type countdown equals time to frames, open parentheses, out point minus time, close parentheses. To understand what this code does, let's temporarily copy it to the source text property. As you can see, this expression returns a counter that goes from the total number of frames for the layer down to 1. This is exactly the time in frames, but in reverse. Let's clear this expression field and turn to our expression selector. We will compare this countdown value against each line index number, and if they don't match, that line will be scaled to 0. type countdown equals text index question mark 0 colon 100. This code is a simple way to write a one-line if-else statement. In plain English, this line reads, if the countdown value matches the line index, set the scale animator effect to 0, else set the animator effect to 100%. Now lower the scale value to 0 and go to the end of the layer. Magic, huh? Only the first line remains visible. Go backward one frame and you'll see just the second line. The third frame backward reveals the third line and the fourth line is revealed on the fourth frame from the back. That is the last instance of a match between the countdown value and the line index number. From here on, the countdown value will always be greater than the number of lines. That's why the scale effector influence is 100%, which means all the lines will be scaled down to 0. We want the text visible one line at a time for the last frames of the layer, but also visible as a block for the rest of the layer's duration. So we'll adjust our expression a bit. Add this bit of code before the question mark, or, expressed with 2 vertical lines, countdown is greater than text total. In English, the expression reads, if the countdown value matches the line index or is greater than the total number of lines, the scale animator effect will be 0%. For any other case, it will be 100%. We have now managed to separate the text line by line only at the last frames of the text layer. Those frames will serve as the reference for the border of each line. Let's build those borders now. Add a new text layer, call it Borders. Parent it to the main text layer. Match both in and out points with its parent. This is very important. Besides, what's the point of having borders where there's no text, right? The borders are just rectangular shapes, so we'll make use of a special character that draws a rectangle on the screen. That character is the lowercase g in a built-in font called Webdings. Let's test it. Change the font to Webdings and type lowercase g. There you have it, a box. Nothing special there, but let me further explain my idea of a procedural border builder. We will generate one box per line and scale it to fit the bounding box of that line. The font size in After Effects is expressed in pixels. We can have the font size of the boxes set to 1 pixel, giving each box 1 by 1 pixel dimensions, and then multiply them by the width of the bounding box for each line and the height of the main text font size. That will fit each 1 by 1 pixel rectangle to the corresponding line of text. Now let's put those words into code. Expand the source text property, add an expression and type border text equals, in quotes, g \r dot repeat, open parentheses, this layer dot parent dot text dot source text dot split, open parentheses, in quotes \r dot length -1, close parentheses. And then continue border text plus equals, in quotes, g. We create a variable called border text, add a lowercase g together with a new line character, and repeat it as many times as there are lines in the parent layer source text. I use the split function to separate the main text into lines and get the total number of lines with the length attribute. For the last line, I don't want any new line added, So instead I subtracted 1 from the length of the lines and added just a lowercase g. This may sound more complicated than it is, but basically we generated one rectangle shape for each line. In the latest versions of After Effects, we can make changes to the style applied to our text using expressions. We'll copy the layer style from the main text and make some changes specific to our border text. Type this layer dot parent dot text dot source text dot style. This copies the style and all its properties from the source text of the parent layer. Now let's override some of those properties, starting with the source text. Type dot set text border text. To visualize the code better, split this part of the code into separate lines. Continue typing dot set font webdings dot set font size 1 dot set all caps false, set small caps false, and in the end, let's override the fill color. We want our borders to have their own color independent from the main text. Type set fill color in parentheses style.fillColor. Now the border text is tiny. We set the font size to 1, remember? Let's temporarily comment out the line of code that sets the font size. As you see, the borders count matches the lines number of the main text. Change the leading amount. The border text updates accordingly. Uncomment the line of code that sets the font size, and let's take care of resizing the borders to fit the text. Add a scale animator to the border text layer and get rid of the range selector. Remember, our font size is set to 1 pixel, so the default 100% scale represents still 1 pixel in size. To resize the box to 50 by 50 pixels, we multiply that 50 pixels amount by 100% in X and Y. To make the boxes 150 pixels wide and 50 pixels high, we set 150 times 100 for the X and 50 times 100 for the Y dimension. Let's set the maximum scale of the border to some huge amount, 5000 times 100, in both X and Y. This is not necessarily the size of the borders, just the upper limit it can reach. Add an expression selector and make it based on lines. Expand the amount property and let's edit the expression field. Type X equals this layer dot parent dot source rect at time outpoint minus frames to time inside parentheses text index minus endpoint dot width. You may have guessed what this line of code means. The source rect at time function returns the bounding box of a layer, and we can take as a reference a specific time on that layer. Going backward from the layer's out point, each line of the border layer will reference the width of the corresponding main text line, based on the line index number. So border text line 1 gets the width of the bounding box of the main text line 1. Border text line 2 gets the width of the bounding box of the main text line 2, and so on. The source rect at time function takes time in seconds as an argument. That's why I'm converting text index from an integer number representing frames to time in seconds before subtracting it from the layer's out point. I also subtract the in point time value so that this reference point stays fixed even when I offset the layer in the timeline. Keep in mind that the expression selector runs on every line, so this expression returns an array of width values. We're then storing this array of width amounts to a variable x. For the height of each line, we'll make use of the font size of the parent layer. Type y equals this layer dot parent dot text dot source text dot style dot font size. The font size is a constant value, so all the borders will have the same constant height based on the font. In the end, we will return the vector xy. Don't hit enter yet. The expression selector should return a percentage value. So let's normalize our values, cut the x expression and type linear, open parentheses, paste the expression inside the braces, close parentheses. We need to fit the result of this expression from the range 0 to 5000, our maximum size limit, into a range of 0 to 100%. Same for the y variable. Cut the expression and paste it as an argument to the linear function. Then fit the range 0 to 5000 to 0 to 100% and hit enter. Now we have borders that fit each line perfectly. You can adjust the font size and the leading amount of the main text, and the borders will follow. You'll surely think that these borders need some margins, and you're so right. Instead of pixels, let's have the margins based on the font size also. At the top of our code, type margins equals open square brackets 1.0, 1.5, close square brackets, times this layer dot parent dot text dot source text dot style dot font size. This is a vector that holds the separate margin values for x and y. I'll start with a horizontal margin equal to the font size and a vertical margin of 1.5 the font size. You can later change it to your heart's content. Let's add the x component of this vector to the width amount of the bounding box for each line, and also replace the font size value with a y component of this vector. Hit enter. Now adjust the font size and leading amount of the parent layer accordingly and enjoy the borders with custom margins. All looks fine and good. Right now the borders work with central alignment, but don't follow the text when we change it. Let's take care of the alignment now. Remember, our borders are rectangle characters of just 1 pixel, so changing the alignment will not really affect their appearance. So we will need to offset them horizontally using a position animator. Rename it to alignment. Delete the range selector. Let's set the maximum offset amount to the width of the comp and leave the y offset to 0. Replace the range selector with an expression selector and set it based on lines. Erase the default line of code. Every border will reference the point in time when the corresponding line is displayed separately in the comp window. So we will need the counter going backward from the out point of the main text layer again. Type countdown equals out point minus frames to time text index minus endpoint. This will return a time value expressed in seconds for each frame going backward from the out point of the main text layer. We converted this time in seconds because that is what the source directed time expects. Time in seconds, not in frames. Also, we subtracted the endpoint time value, so this reference frame stays constant independently from the layer's starting point in the timeline. We will feed this time value to the source rect@time expression and get back the most left position value of the text line, together with the width in pixels of each line. We will make use of them to calculate the center position of the bounding box. Let's type L for left equals this layer dot parent dot source rect@time in parentheses countdown dot left. W for width equals this layer dot parent dot source rect@time in parentheses countdown dot width. And finally, L plus W times 2 will return the center position. As I've mentioned again and again in my previous tutorials about this subject, this code will run once for every line of text, so it will return an array of values, which we will need to normalize to a range of -100 to 100%. So cut this part of the code and type linear, open parentheses, paste it here, and then continue minus width, -100, 100. This ensures that the border follows the text wherever it is within the range of the composition width. Hit enter. Let's test the alignment. The borders follow each line to the pixel. We can modify other text properties as well using other text animators. I like to have each other border with a separate color, so we'll add a fill color brightness animator. Remove the range selector and increase the brightness amount to 100%. Rename the animator to color and add an expression selector. Set it based on lines. Expand the amount property and replace the default code with this one. Text index modulo 2 times 100. This will brighten every other line. Of course, you can easily turn off any text animator by unchecking the eye icon beside it. One last thing. If you worry about the fact that during the last frames of the layer, when the lines of text are displayed separately, you can still see all the other empty line borders, put your mind at ease because those frames won't be rendered anyway. But if you're still not comfortable, you can remedy this by copying the scale animator from the main text layer and pasting it to the border layer. This animator scales to 0 all borders whose matching text is empty. Keep in mind that every animator and expression selector we pile up adds calculation time on every frame of the animation, so use them sparingly. This covers the procedural generation of text borders. You can change the text, alter the font size, leading amount, or paragraph alignment, and the border will automatically follow. All this without cluttering the timeline with countless text and shape layers.